Good morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic about motors and starting of the motors, which are mostly used in industries. These are the key points which I am going to discuss, like introduction to the motors, what are the types of electric motors, its characteristics, starting methods, the direct online starting, star to delta starting, auto transformer starting, soft starters, and variable frequency drivers, as well as comparison of different starting methods and starting currents, as well as its impact. First one is introduction to the motors. What is an electric motor? Electric motor is a device which converts electrical energy to mechanical energy. That means the input is electrical and output is mechanical. So the motor converts electrical input to mechanical output. It works on the principle of Faraday's law of electromagnetic induction. So, by using the Faraday's law of electromagnetic induction, it will be taking the supply, that is electrical input, and based on the supply, it will be converting that electrical energy to mechanical energy. What are the different applications of motors? Motors are used in various applications like industrial machinery, HVAC systems, household appliances, in electrical vehicles, and in many applications. So these are only few applications of motors. What are the different types of motors? There are different types of motors like AC motors as well as DC motors. If the input supply to a motor is AC, we call it as AC motor, and if the input supply to the motor is DC, we will call it as a DC motor. The AC motors are again subcategorized into two types, that is synchronous motor as well as induction motor. Synchronous motor. The first one is synchronous motor, which operates at a constant speed regardless of the load. Synchronous motor. Actually, the motor runs at a speed of ns, that is synchronous speed. So, the synchronous speed as well as the synchronous speed is constant in synchronous motor. Whatever may be the load, the speed of this particular motor is constant. So, the first one is synchronous motor. The second one is induction motor. Induction motor, it is mostly used to operate with variable speed. That is, it can operate on the principle of electromagnetic induction. Both the DC motors as well as AC motors works on the Faraday's law of electromagnetic induction, but synchronous motor works with a constant speed and induction motor with a variable speed. Both works under principle of electromagnetic induction. Here you have single phase motor as well as three phase motors. If the input supply given to the motor is single phase, we call it as single phase motor. If the input supply given to the AC motor is three phase, we call it as three phase motor. So these are the different types of AC motors. Next one is DC motor. In DC motor is being categorized into two types, that is brushless as well as brushed. Means the first one is brush, means brushes are there in this particular motor. They uses brushes to transfer current to the rotor. To transfer current to the rotor, these motors uses the brushes. The second type is brushless, means they use electronic commutation for transferring the current to the rotor by eliminating the brushes. They will not use brushes here. They will directly use the electronic commutation to transfer the current to the rotor. So these two are the different types of DC motors. What are the motor characteristics? The motor characteristics, the first one is speed torque characteristics. The synchronous speed at which the magnetic field rotates. You'll be having an RMF in your rotor or in your motor. RMF is nothing but rotating magnetic field. Rotating magnetic field. The speed of this particular rotating magnetic field is nothing but your synchronous speed. Is nothing but your synchronous speed. So the synchronous speed is the speed at which the magnetic field rotates. The next one is torque. The rotational force provided by the motor. Torque is nothing but the rotational force provided by the motor. The next thing we have to consider is efficiency. The efficiency depends upon the motor type, its load and operating conduction. Like which type of motor are we using, whether it is a DC motor or an AC motor, synchronous motor or brushless motor. So based on the type of the motor and based on the load which is connected to the motor and based on the operating conditions as well as the temperature. So based on all these factors, the efficiency varies of a particular motor. Next one is starting current. When a motor starts, it can draw 5 to 7 times of the full load current. Means for starting of a motor, it requires almost 5 to 7 times of I maximum. I maximum is the maximum current, or you can take I full load. So it takes 5 to 7 times of full load current for starting of a motor, which can cause voltage drops in the supply. Means if number of motors which are being used are more, the starting current will be more, and when the starting current is more, the voltage dips will occur. Because of this voltage dips, harmonics occurs, and because of this harmonics, the overall efficiency of the system reduces. So next one is power factor. The phase difference between voltage and current. Is nothing but your power factor. Motors generally have a lagging power factor, especially under the load. Means motors are nothing but the inductive loads. You may be having different types of loads like resistive load, inductive load or capacitive load. So resistive load will not affect anything on the power factor, will not have any effect. The inductive load will make the power factor to lag, and capacitive load will affect the power factor to lead. So the power factor lags because of this inductive load, that is motors. Starting methods of motors. What are the different starting methods for the motors? Why control motor starting? That is, motors, especially large motors have high inrush currents. High inrush currents means starting current. Inrush currents means starting current, which is almost 5 to 7 times of I full load. As I said previously, the starting current of a motor is 5 to 7 times that of the full load current when starting only, which can cause voltage dips. As the current increases, voltage reduces. Next one is mechanical stress. Mechanical stress on the motor increases. Increased wear and tear. The wear and tear of the motor increases, as well as the power quality issues may occur. So all these are the different effects because of this increase in starting current. What are the starting methods overall? So for reducing these effects due to the starting inrush current, what are the different starting methods which are being used? The first one is direct online starting. Second one is star delta starting. Third one is auto transformer starting. Next one is soft starting, like using the soft starters. The last one is variable frequency drives. By using the variable frequency drives, we will be starting a motor. First one, direct online starting. So in this method, DOL starting, which is also called as DOL starting, the motor is connected directly to the full load voltage. It is connected directly to the full load voltage, and this is the simplest and most economical method. As we are already connecting to the full load voltage, the initial current will be more, and so that we can start the motor. What are the advantages? What are the advantages in this particular starting is simple and inexpensive. It is very simple and it is not that expensive. The second advantage is quick start. We can start the motor quickly. What are the disadvantages? Disadvantages is high inrush current. As I said, 5 to 7 times of the full load current, and can cause voltage dips, particularly for larger motors, means more capacity of motors. This is used for mostly small motors for small applications like in fans, pumps, and for small compressors. For small loads, for small applications, we will be using this DOL type of starting for a particular motor. Next type is star delta starting. In this method, the motor windings are initially connected to star configuration. The motor windings are initially connected to star configuration to reduce the starting current. In order to reduce, we will connect in star connection first. After the motor reaches a certain speed, the windings are switched on to delta configuration. That means initially the star configuration is there. Later on, this is being converted to delta configuration. Okay, this is star delta starting. What are the advantages? What are the advantages are like, it reduces the starting current. It reduces the starting current to almost 1/3 of the DOL. When compared to the direct online starting, when compared to that, it reduces about 1/3 of the starting current, and less mechanical stress compared to the DOL. When compared to the DOL, the mechanical stress is less in this particular method of starting. What are the disadvantages? It is complex control circuit. That means the star connection is there as well as the delta connection is there, and the transformation should be done from star to delta after starting of a motor. This is little bit a difficult or a complex circuit, and it is not suitable for motors requiring high starting torque. when the starting torque of a particular motor is high. If we want high starting torque motor, for that particular motors, we can't use this particular star delta starting type of motor. So mostly typical use is motors with high ratings up to 100 HP, that is horsepower up to 100 HP. We can use this particular starting method for a motor, such as pumps as well as compressors, mostly for pumps and compressors. What is the next type? Next type is auto transformer starting. The third type is auto transformer starting. In this type of method, an auto transformer is used. Auto transformer is used to reduce the applied voltage during the startup. That means during the starting of a period, the auto transformer is used to reduce the voltage. This reduces the current drawn by the motor during the startup. And once the motor reaches the speed, the auto transformer is bypassed, that is disconnected, and motor runs at full load. That means initially they will not connect to the full load, they will connect it to the minimum load, and by using the auto transformer, we will reduce the initial voltage, the starting voltage, and once the motor picks up to the speed, then we will disconnect the auto transformer and we can connect the full load to the motor. This restarting, what are the advantages of this particular starting? It reduces the starting current to 2 to 3 times of the full load current. Previously, it was 5 to 7 times in DOL, direct online connection. Now it is 2 to 3 times in auto transformer connection. So, second advantage is it provides a higher starting torque when compared to the star delta. In previous star delta connection, we cannot use for high starting torque. So, this particular auto transformer method can reduce the initial current as well as can be used for high starting torque also. What are the disadvantages then? The disadvantages are more expensive than DOL and star delta. And as we are using an auto transformer here, the cost of the transformer increases and it becomes more expensive when compared to the remaining two types of starting methods, and more complex and requires an auto transformer. It is the second disadvantage. It becomes more complex. What is the use? Where do we use this type of starting method? Is motors with high starting torque requirements. For this particular requirement, we will use auto transformer type of starting method, such as in crushers, mills, and large pumps. For crushers, mills, and for large pumps, we will be using this auto transformer type of starters. Next one is soft starters. Next type of starter is soft starters. What is a soft starter? Soft starter is gradually increases the voltage of the motor. It gradually increases the voltage of a motor by limiting the inrush current and ensuring the smooth start. It often uses thyristors to control the voltage and provide a soft controlled ramp up of voltage speed. That means that initially the voltage is very less and slowly the voltage is being increased to the full load level, and the voltage is being increased using the thyristors. The control of the voltage is being done using the thyristors softly, and the voltage is increased gradually or slowly. Next one is advantages. What are the advantages of this particular type of starting? Significantly reduces the inrush currents to about 1.5 times. Previously, 5 to 7 times for DOL, 2 to 3 times for auto transformer, and now it is less than 1.5 times for soft starters. Soft starters. So, it reduces the mechanical stress and improves motor life and adjustable start and stop times. As we are using the thyristors here, we can adjust the start as well as the stop times also. Then what are the disadvantages? The disadvantages are it is more expensive than DOL and star delta and does not provide speed control. It does not provide any speed control. We cannot control the speed. The speed is fixed. And this is mostly used in pumps, conveyors, fans in various industries. So these are the soft starters. Next one is variable frequency drives, VFD. Variable frequency drives, VFD provides a smooth start for controlling the frequency and voltage supplied. Previously only voltage used to be controlled. Now frequency as well as voltage both are being controlled in this particular method. And controlling the motor speed and torque. By using the frequency as well as voltage, we are controlling the motor speed and the torque. VFD allow full control over motor speed. Full control over the motor speed, which can be adjusted during the operation. As well as during the startup also. So, what are the advantages? It provides excellent motor control. Smooth start as well as stop, and energy saving is done. And second advantage is it controls the speed as well as torque. It improves the overall efficiency. It reduces the mechanical stress as well as inrush input current as well as the power surges. Power surges means spikes, increase in the power, sudden increase in the power. What are the disadvantages? The higher initial cost. The initial cost is very high and requires more complex installation and maintenance. It requires more complex installation as well as maintenance. Where do we use this type? The high-end application requires precise speed control such as in HVAC, high voltage AC systems, robotics as well as advanced industrial processes. So mostly in industries and in high voltage AC applications as well as in robotics, we will be using this particular VFD type of controlling in the motors. Next one is comparison of the starting motors. Different comparisons. Here you can see 5 to 7 times of rated current, 1/3 of the rated current, 2 to 3 times. It is reduced to 2 to 3 times. Now it is reduced to 1.5 to 2 times. And in VFD it is less than 1 time of the rated current. Here the starting torque is low. It is low to moderate, moderate to high, low to moderate, and it is adjustable. So in VFD, the starting current is less as well as it is adjustable, and it is simple, moderate, complex. This is complex. Here you can see the cost as well. Low, moderate, high, high and very high. Because the controlling is very good here and the number of components which we are using is very high. So the cost is also very high. Next one, here the application DOL we will use in small motors and fans. We will be using in moderate sized motors, heavy industrial crushers, pumps and conveyors. This is mostly used for HVAC systems, high voltage AC systems. So this is the comparison of different types of starting methods of a motor. That may be a DC motor or a AC motor. Starting current and its impact. What is an inrush current? Inrush current is nothing but the starting initial current. The initial surge of current when a motor starts, which can be 5 to 7 times the rated current. It is nothing but the inrush current. It can lead to voltage dips. As I said, as the current increases, the voltage may reduce, which will cause reduced equipment lifespan. That is, the lifespan of the motor may reduce, and increase losses in distribution lines. As the voltage changes, the harmonics increases. As the harmonics increases, the efficiency reduces. So, how to manage the inrush current? By using the appropriate starting methods. Like previously we have seen different starting methods like DOL, start to delta, soft starters and VFDs. So, we should use the appropriate starting methods in order to manage the inrush current, and proper system design and sizing of the circuit protection devices. Proper circuit protection devices like circuit breakers also should be connected, and use of VFD for energy efficient and smooth start. We can use VFD, but the initial cost increases. So, for high applications for industries, we will be using VFCs. For low industries or for low applications, we will be using soft starters or star delta starters. Next, key points. For selecting the appropriate motor starting method, it is essential that we should ensure the motor longevity, system stability and energy efficiency. All these things should be considered for selecting a motor, and each starting method has its own advantages as well as disadvantages. So, based on the application, based on the cost of the load, we will decide which type of starting method is being applicable for that particular load. In next class, I would like to discuss about SLD, that is single line diagram, and cable and switchgear selection. Thank you.